Well, I guess we can kick things off. Thanks for everybody for coming. I put this talk together on somewhat short notice, so excuse the lack of polish. And the preferred talk style, feel free to interrupt me at any point, ask questions. This will be pretty conversational. So the title of my talk today is using Ethereum, React Native, and the Tasit SDK to build third-party mobile clients for dapps. And dapps are decentralized apps. And we'll dive a bit into what that means in a moment. As for who I am, I'm a software engineer and an entrepreneur. Lived out in the Bay Area for a while. I've been doing startups my whole career. Worked at a YC company there as the first employee and CTO. Relocated to Chicago about 1.5 years ago, and I've been freelancing as an Ethereum freelance developer and smart contract auditor. And recently I founded a company to build a product in the Ethereum React Native world. And that's my Twitter handle if you want to follow me or ask any questions after the fact. So what to expect today? First, I'll just quickly do an intro to Ethereum. Basically, just make sure there's a common vocabulary for the rest of the talk. And especially feel free to interrupt in that section, because I'm assuming there's a range of levels of familiarity with Ethereum. The second piece of the talk will be building a JavaScript SDK that abstracts away some of the low-level blockchain details and just treats it as kind of any old backend. And then the third portion of the talk is how to build apps using that abstraction. So let's start with the intro to Ethereum. And here, the visual design is not great. I'm just going to rattle off some concepts and quickly explain what they are. So Ethereum itself is a successor to Bitcoin. It is an instance of a blockchain. A blockchain is basically a shared record of truth between a bunch of machines. People are incentivized to run different computers running this protocol. And at the end of the day, it's basically just a hash table mapping balances to accounts for how much value people have. What's unique about Ethereum, though, is that it's also programmable. So you can set special if-then rules for maybe rather than I send you cash right now, if a certain set of conditions are true, then a value transfer occurs. And you can get pretty fancy with what you can build on top of that primitive of value and trust. So one concept on Ethereum are accounts. It's basically just a public key that says this is me, and there's a private key associated with that you can use to sign transfers of value on behalf of that public key. And that's pretty much all it is. If you're used to public and private keys, there's nothing fancy going on there. In practice, what it looks like is a hexadecimal string. I talked a bit about private keys, but basically that's a string of length, a hexadecimal string of length 32, which corresponds to an address of length 64. And you need to keep these secret, and this is your way of proving that you're authorizing a given transaction. Wallets. This is basically an abstraction on top of accounts. It's, okay, I have a private key, I have a public key, but now I want to do things with that in a relatively user-friendly way. So a wallet is a piece of software that lets you create transactions by doing things like clicking buttons on behalf of that public and private key pair. Sometimes it's a mobile wallet, sometimes the private key might be held on a dedicated hardware device that interfaces with a simpler software interface on, say, your PC. Now, contracts. That's the thing that makes Ethereum unique when compared with Bitcoin. That's the programmability bit. Compared with other tech terms, I kind of just think of them as cloud functions, basically. At the end of the day, there's just some inputs and some outputs that change the state. There are some economic primitives that you need to understand to get at a low level how they work, like how you pay for them being run. The cloud function on Google, you just have billing set up and then they charge whatever spinning up that one instance of that function costs. Similar model on Ethereum, but the concept is called gas, which we'll get to in a moment. Just before we rattle off too many concepts, if you wanted to explore how this all looks in practice, there's a website called Etherscan that lets you look at how, what has this account done recently? Has it interacted with this contract with this address, has it sent value to this other account address, and it's pretty much just a very simple UI for looking at that. And there are a few other ones, but for the sake of time, I won't go into too much detail on them now. Right now, pretty much all of the contracts in use are written in a language called Solidity. If you've used languages like JavaScript before, it should look pretty familiar to you. It is typed, largely because of blockchain size constraints. So if there's a bunch of computers all around the world, all processing these transactions, over time, that's a lot of data building up. And so sometimes it's useful to have like a uint of size 8 as opposed to a uint 256. So that's part of the reason for the typing, among other security reasons as well. But yeah, it's basically just, again, if you're used to JavaScript, it's a relatively approachable language for writing these cloud functions that cause state transitions on the Ethereum blockchain. And we'll look at some samples of that later. Again, if you're used to kind of a modern dev tool suite, you probably think about testing. How do we test these things that we're writing? Truffle is what most teams so far use to do that. It's kind of just an abstraction around Mocha, basically, if you've ever used that in JavaScript. But yeah, you can do TDD and Solidity before deploying your contracts so that you can be somewhat sure that they'll perform as you expect. Now, you should still have proper security audits for a whole host of reasons. But again, I'll move on for now for brevity's sake. So once you have that primitive of contracts, which are just functions, you might find different developers doing, having the desire to have their code stay dry, not just with their own code, but with what other devs are doing. So because this is all open source, there are these ERC standards that crop up. So it's like, if you want to have a function whose job it is to create a new play form of money and transfer that between people instead of the core ether, that's like the baseline money on the protocol, there's a standard for doing that, and that standard is called ERC20. You can look it up on GitHub, and it's basically just a collection of functions for how to trigger these state transitions, but it's nice that the community coalesces around them, because then it's easier to make UIs on top of it. It's easier for, even if someone's interacting with the blockchain just from like the command line interface in their terminal, it's nice that there's a standard function that they know they can call for different instances of a similar thing. And largely because of that, there are software solutions cropping up that make it easier to use those standards. And Open Zeppelin is one of these. It's a Solidity library so that rather than reinventing the wheel with your smart contracts, you can reuse a lot of their code, import, say, an interface or a collection of math functions that perform math more safely in the Solidity language. And yeah, you just inherit from those contracts and then add that one piece of your special business logic on top of that. It's a pretty cool library, and probably, along with Truffle, the best places for traditional developers to begin exploring this type of thing. So again, on the TDD topic, once you've written all your unit tests, you've run them locally, you probably want to set up CI/CD, and maybe once it's merging to your develop branch, you actually want to run those in a more production-like environment, run that same test suite. You can do that using test nets. There are basically like alternate versions of the main Ethereum network of computers, and there's test ether on those test nets. In a sense, it's free. You can go to a website and say, this is my address, please send some to me. But also in a sense, it is scarce, and devs are using this regularly to test their contracts before deploying them to production. And so it ends up kind of having some intrinsic value. Like you actually might pay someone to send you a lot of it just so you didn't have to keep going to some website to refill your company's dev account with test ether. And a new one just launched the other day called Borley, that's trying to codify the role of the different test nets that are out there right now. I alluded to gas before, and there aren't too many concepts left, so bear with me. I alluded to gas before. That's basically given that you can basically run Turing-complete programs on the Ethereum blockchain, you need a way to make sure that it won't run forever, because that would break the whole thing if even one contract was doing that. So when you're calling a function that would trigger a state transition, you say, when I'm running this function, I think there should be no more than this many steps in the code. And gas is an abstraction kind of based on gas for your car. It's like you fill your tank up once to go 200 miles. I don't know, I don't drive that much, but something like that. Same idea. Different opcodes in the language that the solidity is compiled down to cost different amounts of gas. So for each line of code that you run, there's a fixed gas value. And then on top of that, there's a free market, so that at any given time, there's a different price for gas. But long story short, it's pretty similar to AWS or Google billing you every time a cloud function runs at the current market rate. Mining, again, I'll kind of brush past this, even though it's a whole topic in its own right. But in order for there to be lots and lots of computers powering this network, you need to incentivize them somehow. And you need to make sure that they're not cheating. So the way that you make sure that they're not cheating right now is by making it very computationally hard to compute a valid new state of the blockchain. And you incentivize them by rewarding them with the native currency of this platform, Ether. That's a very quick version of that. So back on the ERC standard topic, one of the ones that's really taken off is this idea of tokens. Part of the reason it took off a lot was it was an easy way for teams to fundraise for their projects. So they would make a new currency, make some story about how it will eventually have value, and sell that to people, and people would buy it in Ether. That of course brought on some scammy-like behavior, but a lot of real, valuable, interesting behavior too. But like any ERC standard, it's basically just an interface and a collection of methods you can call to trigger different state transitions. So for instance, I might say, I'm going to make a new token called Paul token. My name's Paul, and there's 30 of them, and I'll give each of you who came to this talk one of them. And here's the function you call if you want to send them to somebody else. So if someone tells you their address, which is pseudonymous, it's not anonymous, because you can use metadata to figure out what address corresponds to which person based on their behavior, but it's pseudonymous in that only if you do things that provide that metadata trail would it be clear which account corresponds to which real world person. But, so if you want to send this fake Paul coin to someone, I can tell you my address, and then you can send it to me through perhaps a wallet interface we discussed before. Like you might download a mobile app for your phone that lets you hold any arbitrary ERC20 token, and now just by opting into saying I want to use Paul token, you have the ability to transact that with other people. Again, kind of hand wavy, but we need to cover a lot of ground here. So some of the coolest things, in my opinion, that can be built on top of Ethereum are when you kind of have the insight that, hey, this is now a network. We don't have to trust any centralized entity, so there's no need for middlemen, and it's programmable, and value is native to the protocol in a way that wasn't true of the internet ever before. So like in HTTP, they thought about having one of the codes be for whether a payment was successful or not. It ended up not making it into the protocol. But I think a lot of the ways that the current internet is having a lot of issues these days is because payment isn't a primitive. So like advertising ends up being the model that's bolted onto it. And we see that's kind of gone in the surveillance capitalism direction these days. But it's interesting because it allows for a lot of business model innovation when payment can be built into the application you're building as like a primitive piece of it. And the apps that will be built on top of it aren't necessarily clones of the current web apps, but new crypto native things that wouldn't have been possible before. In the same way that like Instagram was a great fit for mobile because there's a camera in your pocket all the time. Or Uber was a great fit for mobile because there's a GPS on your phone. Whereas those things weren't great fits for PCs. there are new types of dapps, decentralized apps, that will crop up where there's this new core primitive of trust and payments built in. So some examples I'll rattle off quickly. NFTs is a jargony word for basically like baseball cards on the internet, digital collectibles you might call them. It doesn't always have to be something that cutesy. It could be like a reputation system, but basically, unlike currencies where each unit is the same as any other unit, each of these is unique. So there's a given Babe Ruth rookie card, then there's one of those. Stablecoins is another abstraction on top of the core Ethereum protocol. Although in theory it could be with any blockchain. And the way that works, well, there are 3 ways you can build it, but the most famous one is if you collateralize a given token with Ethereum, which has a volatile price, but then you algorithmically make sure that you're buying or selling this other token based on the current supply and demand. You can have it, as a result of that, pegged to any value you want. So you might peg it to the value of Bitcoin, or in the case of the most famous one, it's pegged to the value of the dollar. So then instead of not wanting to buy a pizza with Bitcoin because you might find out it would have been worth $1 billion later or something, the protocol built on top of Ethereum can ensure that $1 is always one stable coin. DeFi, you can kind of follow a rabbit hole down that path and think of rebuilding a lot of financial primitives on top of Ethereum, like how loans might work, yada, yada, yada. Value does not necessarily mean only money. Any kind of scarce thing of value can also be built on top of the Ethereum blockchain. And so like what university you went to could be thought of as like a valuable piece of your reputation, even though it's not a currency per se. It's like a reputation which has some value. So there are lots of instances of DAOs. There's one, I should define the term first. Decentralized autonomous organization. It's basically just like a meetup group on the blockchain or something. You can add people to the meetup group. But these meetup groups can manage crazy amounts of funds, and it could go in a lot of directions, but it could end up being as fundamental as the invention of the limited liability corporation. It could be like the new model through which people organize and achieve common goals on the internet. But certainly a big buy. Some people think so, some people think not. Other dapps are, this actually relates back to the DAO one a bit, but token curated registry is basically just a list where the members of the list are stored on a blockchain, and the state transitions are adding or removing people from the list, or it could be an ordered list, and then it would be moving people up and down in that ranking of the list. But in the university example, you might maintain a list of all the people that got into your digital university or something, and that could be done with a TCR. Marketplaces, I'll start flying through these a little bit. Marketplaces, you can let people trade things like the digital baseball cards. You can make a marketplace for that and put a front end around that. Prediction markets, you could bet on outcomes in elections. People have built apps for that. But back to the nuts and bolts of how you might do any of these things. The way most people use them right now is with a tool called MetaMask. That's a browser extension. Right now it only works on PCs. There will be mobile support in the future. It injects your wallet into your browser so that when you visit a website, you can let that website have access to that wallet, and then you can do the payments kind of as if it had been a core feature of HTTP. Infura is, so again, this is a network of computers running this thing. Not everybody wants to bother setting up their own computer and storing all the state of the blockchain on it. It's not that much state, but just from like a DevOps perspective, keeping it live can be a headache at times. So a lot of dev teams are pointing to Infura, which is basically just a big hosted cluster that makes a node available of the Ethereum blockchain. Which brings me to what a node is. A node or a client is basically just a piece of software. Sometimes it'd be written in like Go or Rust or other programming languages. There's a Java one. And it processes these state transitions. Well, it's different whether you want to be mining or not, but a node can also be what the protocol through which you send transactions from the UI of your app and then actually hitting that network of machines running this blockchain. Concepts of governance come up. Ethereum's kind of softly governed, where it's basically just like a loose consensus of everyone on the internet with what people are saying on Reddit and Twitter, and then that kind of guides thought on when the software should be upgraded or not. And then the people running mining software also kind of are part of that soft governance where they can opt in to or opt out of software upgrades. There are thought leaders, you might call them, which people argue is somewhat centralized, but it's no single entity has the power to push through software changes in the protocol. So there are other blockchains where governance is a more core primitive, and there's a lot of debate on the right way to do that. Let me see how I'm doing on time. I think I should. Okay, I think I'm okay. Serenity is the next version of Ethereum. A lot of it is similar to what I've described so far. The main differences are being able to write contracts in languages other than just Solidity. They're using some of the WASM work from the regular web to let you compile different languages down to the same bytecode. And two other changes. So because I mentioned the state of the blockchain is growing rapidly, the protocol is being changed so that not all of that state is on everyone's machine. So it's sharded, like you might do with the database. And the final change is that rather than, so the mining piece is different. Right now, with Bitcoin and Ethereum, mining works by doing a very computationally hard problem on a dedicated GPU, or perhaps even like an application-specific integrated circuit, an ASIC. And you're basically spending whatever you pay for your electricity to have that constantly running and doing a very hard computational problem. And as a result of doing that, you're rewarded. That makes it hard to, you're better off having one of those and dedicating all your computational resources to it, rather than having like, it's like, why wouldn't I just make 10 versions of myself and mine 10 times instead of 1 time, so I get 10 times the reward. But the algorithm is designed such that you would actually end up making less money by doing that. The change in Serenity is that rather than buying like an expensive GPU or an expensive ASIC, you would just have to prove that your account has a certain amount of Ether on it in order to become a validator in the network. At the end of the day, it's arguably the same thing or not the same thing, because you basically have to spend a lot of money to have the right to help with the mining. And those are the 3 core differences in the upgrade to Ethereum that's coming. If you want more info on any of this stuff, ETHub is a new website, but it's pretty high quality, and they recently got some funding for that. So yeah, it's definitely some good intro material there. Why does this all matter? In short, it's a chance to change how some of the power structures globally are structured, and I'm going to kind of brush past this section as well because it could be a whole topic, but I guess from a software engineer's perspective, maybe the most interesting is interoperability. Because this is a permissionless network of machines running this code, no one needs, it's a bit redundant, but no one needs permission to participate in this network. And no one needs permission to run code on top of it. So it allows for an interesting interoperability bit, which is basically to say that the teams making front-end software for dapps can be a different team than the team making smart contracts. And if I draw an analogy to the Web 2 world, that's like if just yesterday, Twitter turned off their API for some third-party clients. Like Crowdfire is one of them. It may or may not come back on. But the difference in the Ethereum world is because it's totally permissionless, these smart contracts are like an API that can't be throttled or can't be turned off. So like from a platform risk perspective, it allows for different startups to be built on top of that. Right now, everything's traceable on the Ethereum blockchain. There are some efforts with other blockchains and even on the Ethereum blockchain to make it possible for there to be state transitions that an arbitrary observer can't decode easily. Again, whole nother topic, but kind of interesting direction for future research. So, I'll pause for a second. That's the what is Ethereum bit. The topic we're going to talk about next is, there's a lot of stuff going on there. How can just like your average developer make something on top of that without worrying about all those low-level details? And so the rest of this talk is based on a project I'm working on that's an open source library to help with these things, but I'll focus mostly on kind of the things I've learned while doing it and how we've been doing it from the code side of things. But first, so why make this open source SDK on top of Ethereum? Right now, all the dapps, decentralized apps that I mentioned, are pretty much just on PCs. There's not much on mobile, but as kind of like a spoiled millennial, I want things to work as native apps on my phone, and most of them don't right now, and that's frustrating. And not really just as a spoiled millennial, globally, people use phones way more than PCs these days. As developers, we can forget that, but most people connect to the internet through phones. Also, probably most of you haven't tried dapps before. I would argue that the reason for that is mostly a UX one. It's just like really complicated to get through all these hurdles and do it. And there are dapps that could be providing real value to you right now, but the fact is that like even the most popular ones have had like 100,000 users, and I think UX is a pretty core piece of addressing that by making it available on mobile, but also just by making it simpler to use those things. And so this SDK we're building should help with that as well. So there's the UX bit, the no platform risk bit that I addressed earlier, which is like no one can shut off your API access, which makes it more compelling to make this open source SDK for building apps. Because like, imagine if you made an SDK for Twitter, it's like, yeah, sure, it'd be nice to use that, but what if they turn it off? So like, the SDK is naturally more useful with the guarantee that the backend can't be turned off. From a user's perspective, what's cool about that is like, now there can be 20 Twitter clients, and if you want to switch to a different one because you don't like the feature in one Twitter client, you don't lose all the data network effect that you had in the original client. So the data is fully transportable. It's not like you have to rebuild all your followers just because you wanted to switch to a Twitter-like thing with a different front end. And inclusion is the last bit. There are some other talks during this conference as well about how like you can bake people's prejudices into AI. That's a real problem, and AI is becoming a bigger and bigger feature of front ends, or of the whole app experience. And so allowing for this right to exit, allowing for there to be 20 different client implementations, guarantees that we can have a more inclusive software world where there are apps that work for different populations of people around the world. So, the Tasit SDK. Why Tasit? It's a misspelling of the word tacit, which basically means you have implicit permission to do something, and that's kind of the core difference with Ethereum. So it's kind of a phonetic spelling. It's also a Turkish word that means vehicle. Just a collection of reasons I think is a nice name. Let's talk about how the project is laid out a little bit. So there's the SDK, and then there are the apps built using the SDK. The SDK itself is in JavaScript. The apps built with it are in React Native, although you could use iOS or Android and still, I'm sorry, you can use like Objective-C or Java or Kotlin or Swift and still use pieces of this library. So on the SDK side, it's basically split out into units of functionality. The SDK is structured that there are 5 child packages that are bundled up and then exported as one big parent package, but you can also install any of the 5 separately from NPM, and they would work on their own. And the pieces of it are these, but I think it's probably easier to go into each of them as the slides keep going. Here's an alternate way of viewing that, kind of how their dependencies fit together. So the SDK, I guess I have 4 packages here that are part of the SDK. Those 4 child packages are all dependencies for the SDK itself. And then we can use the SDK as a dependency to build apps with it. This slide could be time consuming, so I'll just say that the low-level library we're using in JavaScript for interacting with the blockchain is called Ethers.js. It's a really interesting project. If you've played around with Ethereum before, it's an alternative to Web3.js, but basically it's just a simple, well-written library for calling methods on smart contracts, so calling these cloud functions, and for creating those accounts that we talked about earlier, the public-private key pairs. So the SDK I'm building is an abstraction on top of that. And a lot of the functions within it work well in the React Native environment that we're targeting. So creating wallets can work, sending transactions to the Ethereum blockchain can work, and using some of the cryptography primitives wherever appropriate can also work. There are a couple parts that don't work as well in React Native. So instantiating the randomized wallet, it's not a proper source of randomness. There are ways around that basically, well, there are like 5 different strategies, but the best ones tap into the core iOS or Android ways of generating randomness, and then you can expose those libraries as a React Native module, which is then used in the app, which is otherwise all in React Native code. And then this other one's a bit complicated, but like most wallets, and remember wallet is just software around an Ethereum public and private key, most wallets ask you to write down 12 words as the way to have the ability to restore your wallet. Coming from the Web 2 world, it's kind of a weird paradigm shift because we just stopped writing down passwords or using the same password, and now people use password managers. But now in this world, people are thinking, oh, password managers are kind of a centralizing risk of losing all your passwords. So you need to write this down and have like a physical location where you keep those 12 words. Long story short, that is a concern for wallets. They need to think about how the UX should work there. But the SDK we're making here is for native mobile dapps, native mobile decentralized apps. And while there are accounts in those, you might use an example like Venmo. Like if you've used like Venmo or Chase QuickPay or PayPal or Square Cash, you're not going to keep a lot of money in there. It's just kind of, you might keep 20, 50 bucks in there that your friends have sent because you're probably going to send it again to someone else pretty soon, but it wouldn't be the place to have your savings. And so there are different UX implications for the right way to secure 20 or 50 bucks than there are for your savings account. And so I think prompting people to move large amounts of funds to their savings account is better than asking them to use these 12-word phrases to restore them just in a standalone app. So let's see if this works. So we're on GitHub. This is the SDK. Again, child packages. This is the accounts package. Let's see, how's the size? I should probably blow this up a little bit. Ooh, I know how to do that on Macs. Anyone know the shortcut on the PC for doing that? Yeah, it's okay. So you can see in the package JSON that we have ethers as a dependency, and oh, the scrolling's inverted too. And then our account abstraction is pretty simple here. In this case, we're just using a function from within the ethers library and exposing it via a slightly simpler API. this package right now is not the most interesting one, so I'll brush past it. Did we lose which slide I'm on? Let's see. Okay, and then, so accounts, sure. What about interacting with the blockchain? We also have a package that makes that a bit simpler for devs that are used to just writing front-end apps and not worrying too much about blockchain details. And again, this is just calling functions that trigger state transitions on the blockchain. We can check out a bit of that code as well.
Oh, quick.
Yep.
It's just control instead of command.
Oh, okay.
Command and
Control plus.
should be-
Awesome.
yeah.
Thank you. And also, do you know if it's a 3:45 stop or do I have till 4?
Just go to it. You have until 4.
Okay, cool.
They usually say 45, but technically this room's not going to be used
Right.
again, so
Okay.
4 is fine.
All right. So the source for interacting with contracts is a bit more interesting. We have a few different helper functions. The core function of interest here, or the core class rather, is contract.js. I'll just scroll through this. There's a little bit going on here, but I think probably at a high level, what's going on here is what is a contract on the Ethereum blockchain? Or what would you need to do something with that contract? You need to know what its address is, which is basically like, I don't know about on Google Cloud, but on AWS, I think you can even call the URL of a Lambda function. It's kind of like that. Or yeah, I mean, you can expose it with API gateway and give it so it's basically like the URI you use to call it is the address. And then contracts are in this Turing complete language, right? So you can write anything. There could be any set of functions available with that contract. So there's a JSON file, which is like a JavaScript object, basically, represented as a string. And that's just, you can use that to figure out what functions or methods are available for a given contract. So to instantiate a class that lets you interact with that contract, you basically pass in a list of the methods that are available and which ones are like writing state, which ones are reading state, which ones are locked down with a certain set of permissions, like internal or private. Let's see. So at the highest level, we've got a contract that has a constructor. So we've got the address, the ABI, and then the last piece we use for this level of abstraction is what public and private key you're using to, if you say contract dot method number 1, it needs to know what account is calling that function. So when you instantiate the class, this third arg here is who's calling it. So that you don't have to send that every time you want to interact with that contract. You can use this constructor once, and then from then on, it's always happening from that address. But there is another function available for setting the wallet, changing the wallet associated with that contract. You can remove a wallet, get the address of the contract that you use to instantiate that class, and perhaps most interestingly, subscribe to that contract. So I think this is a pretty interesting piece. Like with HTTP or a REST API, if you were saving user data, that would be like a write transaction, basically. And you would wait, you might do like if you were writing JavaScript async await style, you would probably just await what status code and JSON data came back from that REST API saying like user created, here's this user's ID. In the case of the blockchain, remember it's a network of computers all around the world, all trying to reach consensus on state. So you can't just wait for one machine in that network to say we've processed this transaction, because and when a transaction is processed, it's called being confirmed. But it's conceivably possible that there could be 3 blocks added to the blockchain where that transaction is in there. You think you've saved this user data, but then all of a sudden, I'm trying to think of the simplest way to explain this. Another machine comes online and it has an alternate version of the blockchain with 7 blocks on top of a version of the blockchain where that transaction never happened. All of a sudden, it's kind of rolled back, and with each additional block, that gets exponentially unlikely, but you can't just count on it being confirmed once. And so the way this relates back to building dapps, or decentralized dapps, is that you kind of need to do optimistic updates, basically. You should assume it's going to work, but then be sure to be listening to the possibility that something changes later on and that the transaction didn't actually go through. So all that's to say that we use a pub sub style with this library and let people subscribe to events on contracts after they interact with them. I think it's a rabbit hole if we keep going too far there. For the sake of time, I'm going to brush past this onboarding section, but I'll just quickly say that, let's see, a lot of decentralized apps make you create a wallet in order to do anything, but at the end of the day, these are just apps. So like, if this onboarding flow is like, you have to go to a different website, Coinbase, and link your debit card and buy Ethereum, and then come back and download MetaMask and install it as a browser extension. And only then can you even see what's on this website, which is the way a lot of them are built right now. That's super clunky. So a new kind of first-class assumption of this SDK is that things should be in read-only mode as much as possible, and the user should only be prompted to even have an account where they would store funds at the moment that that would happen in the app. So a lot of these contract read features assume presence of no wallet. It also assumes that most users probably are new to Ethereum as a whole. So there are a few new paradigms for how you can subsidize early costs for new users, and that's referred to as meta transactions is one of the pieces of tech there, and that's also built into this SDK, and it should make it easier to onboard users who have never used Ethereum dapps before. And for people who do have funds, everyone right now is building wallets and then trying to make you do everything through one wallet app. The core difference here is that we'll assume that people already have a wallet they're happy with if they're already using Ethereum, and the onboarding piece that we make simple is kind of linking up your account in this app with your primary wallet. And so I'll just brush past that. Okay, a few challenges at this point. There are 2 paradigms for contracts, upgradable and non-upgradable. The implications for what it means to like build a front end on somebody else's back end are slightly different in the 2 paradigms. Again, going back to the cloud functions example, it's like if there was a REST endpoint that always had whatever cloud function the backend devs want to put at that REST endpoint, that's kind of like most of the web right now. You can always, unless you have great API versioning, you can always change the code that runs when you hit an API endpoint. Only recently have there started to be some upgradable smart contracts, but it changes what that JSON file would have been that says what methods are callable on a given contract. So you need to bake into the SDK places where you can change the mapping of what functions are available. Sometimes people index things with servers. That piece gets complicated too. I'll have to brush over that for now. And finally, there are also a lot of security considerations here. So making sure that no one has maliciously published a package with a vulnerability as like the upgrade for a given dapp. So being able to prove the signature of the code you're running. Some teams are like building in ways of like showing
3 unique emoji that correspond to the hash of the distribution code as a way to ensure that you're using the real thing. There are considerations like that here. But for the sake of time, let's jump into the making apps piece. So we're doing it in React Native largely because it's cross-platform, largely because React is hugely popular on the web, and in particular in the crypto world, almost all the front ends are built in React, but I mean, same is relatively true in Web 2. So if we're asking users to now create mobile apps for their web-based apps, it's a pretty natural fit. And I think it's also resonating a lot with like younger devs, so I still see adoption of React Native growing over time. Although I think some of the competing standards, like the one from Google, are very interesting as well, and we could add support for that at some point. Expo is an abstraction on top of it that we use for making a few of those app rollout features simpler, and they add a few SDKs as well that we can use, but that's not the important bit. So how would we install this SDK and then use it in a React Native app? You can install it from npm or yarn, whatever you like. Its package name is the SDK, Tasit SDK, and then it's pretty simple. You can just import one of those child packages, like the account one, and do account.create, and boom, you've got your ephemeral public and private key pair that you can use to do things on the Ethereum blockchain. It doesn't have any funds in it yet, but that's the onboarding bit we were touching on a bit earlier. And again, it's all designed to be modular, so rather than installing it from the Tasit SDK npm package, we also published all the child packages as their own packages, so you could just import the Tasit account bit, or you could just import the interaction with contracts bit. But let's dive into a real example. There's a decentralized app out there called Decentraland. We'll just quickly watch their video. If you've seen Ready Player One, that's pretty much what it is. There's a virtual world, and in Ready Player One, people were like racing around trying to find hidden prizes. You could conceivably build that in Decentraland. It uses the blockchain to store ownership of different parcels of land, and then people are building VR experiences on top of it. And that's pretty cool. It's also arguably kind of silly too, but you know, you could really see a pretty different world in 50 years where this is embraced, essentially. And already people are speculating quite a bit on it, like parcels of land are thousands of dollars, like real dollars. But so these people spending thousands of dollars on this right now have to do it from their computers, and they might miss out on sales of new parcels of land that they want to buy, or they might just want to send some of the land to their friend when they're at a meetup to show them how cool this is, and none of that's possible on mobile right now. So what would it take for us to build a mobile app for that? I'm just going to quickly show you that the marketplace bit of it, of like, hey, this piece of land is up for auction. The way they show the land itself is pretty silly right now. You could always add some better art around it, but it's literally just like XY coordinates for parcels of land. But seen through the VR version of it, each of these is 16 by 16 meters, so you can like walk through different neighborhoods in the virtual land, and what people have built on it change. Okay, I was gonna show their code, but I think we're kind of out of time. But I'll have these slides available after the fact. They've got the land, which is the land is represented as like one of those baseball card things I mentioned earlier, where there's a unique ID for each piece of land, and so they're all tradable. They've got their own currency that you can use to buy or sell that land. That's with the ERC20 standard that I was talking about earlier. And there's a set of smart contracts also for the marketplace, where it's basically like, I have land, this is its land ID, I would like to put it up for sale for this price, and anyone can buy it if they pay me that price. So how could this look on mobile? This is kind of an old video, but it just shows like a quick version of how I picture this working. So you're browsing those parcels of land. Maybe someone decided to send one to you, or maybe you invited 10 of your friends to the app. So it's like, okay, let's get you set up with a way to store that land. I'm new to Ethereum. So a lot of these things are abstracted away. You can just like have like a username as opposed to showing them their long 64 hex account number. And then for actually building what we saw there, for actually building what we saw there, we also have a CLI for scaffolding out a lot of those React Native components and wiring it up with the SDK. So that's, we even have special flags for if it's a given ERC standard, like the baseball card one, it's wired up even more, so there's less to do, so that if someone looks at our code for this decentralized app, they can do it for a different unique token app with very minimal changes. I think let's go through these slides. So, transferring land, selling land, and buying land. For transferring land, you import the contract functionality from the SDK, the stuff for interacting with contracts, and we know that it's one of those baseball card-like ones, the NFTs. So we say, let's set up an instance of the class of NFT, call it contract, and then we create a state transition that we want to do, which is transferring that piece of land. And that's and if we looked at the contract code that I brushed past earlier, there's a function called safe transfer from there. And basically you would just say, pick the address that you want to send it to. I mentioned PubSub earlier. You can subscribe to error events or an event like enough confirmations, like if there have been 7 blocks added to the blockchain on top of this transaction having been confirmed. And then you can send it, here it's using the send meta function because it's not asking the user to pay for gas for that, but letting someone else subsidize the transaction. For selling land, it looks pretty similar. But here we're using arbitrary contracts as opposed to that pre-built one for baseball cards. So the marketplace contract has a function called create order. It's like I was describing in words. You pretty much just pick a price, pick the ID of the thing you want to put up for sale, and boom, it's up there. And then you can listen for whether that transaction went through properly. And for buying it, the last bit is that's not done yet in the SDK, but we're planning on doing soon. There's no reason the mobile app developer should have to be like picking these gas params here. So we're going to have sensible defaults for those, and they'll still be customizable, but a guiding principle for the API design is like as few args as possible, just what you really need to grok what's actually happening. Yeah, cool. So we have a couple minutes left. I'll just show you the repo for this for 2 minutes, and then that's the end of the talk. So now we're not in the SDK repo, but in the Tasit repo, where we have a collection of apps. We've got a demo one, a decentralized one. Still in the early stages of this project, so I'm looking to create a few more there soon. But let's check out this demo one. I don't know how much you've used React or React Native, but the idea is basically that like each part of the screen is a component, and you pass the data into it that it needs to render itself. So almost all of the app is a collection of presentational components. We've got some buttons where it's like, what color should the button be, or what happens when you click it. We've got some of those core onboarding flow things, like setting up your Ethereum, like this one is for I showed that screen where they were picking a username. This is the presentational component that lets them do that. Diving back out of this components folder, the components that store state here are just our screens. It would be a little bit different on React for the web, but here screens are like different routes for the page. And that's where, this is where you can introduce like some kind of state management library like Redux or MobX, but as far as the mobile app developer is concerned, they can basically dispatch an action like they would to a traditional web API, but behind the scenes is using this SDK to do functions on the blockchain instead. And then the last bits I'll show you are the app code itself. This is a lot of like boilerplate, like what happens on load of it, what if there's an error. And then in terms of the navigation, we're using a library called React Navigation, which is probably the most popular one in React Native apps for moving between screens. And the app is just kind of, this is the collection of screens I showed in that video earlier, but the landing screen and then flows for if you're new to Ethereum or not. And most importantly for this decentralized example, listing the lands that are available and claiming one of them. Then a screen that's like within the next week is the buying a parcel of land one. But I already showed the code that we would use to do that. So basically there would just be a new collection of presentational components contained in a screen, and the on click for a given button would be that SDK method for the marketplace. I think it was called execute order for buying land. But that is pretty much it. I'll just close with some links here. If you want to check out any of this, our website's tacit.io. The project is Tacit Labs on Twitter. These are the two GitHub repos here. It's all open source and always will be, MIT licensed, so feel free to play around with it. You could create PRs against it if you're curious. We've got a Telegram, you can email me. Feature requests, we're using a tool called Canny there. Nothing on Medium yet, but that's where our blog posts will live. And then in the interest of like radical transparency, we've got the whole project management bit also on GitHub, so you can see the status of all the issues with this Kanban board. And that's pretty much it. So yeah, thanks for listening.